Hi, good evening everybody. So welcome to this second episode of the OpenHT Season 2 series. So today we are gonna try to keep going on the microphone and especially the timers that we found out yesterday are kind of a trouble for what we are trying to achieve. So on my side, you can see it, but I have an oscilloscope with a signal generator and the Nucleo in front. So what I'm gonna try to do today is connect that signal generator to the channel 1 of a timer and the oscilloscope to the channel 2 of of the same timer, and try to see if I can manage to get a configuration in which the timer behaves as a throughput. So basically I have at the output the same thing as I have on the input. So if I can try to reproduce this kind of configuration on one of the other timers, so it must be one of the timers between 2 and 5, it has to be one of those. Then if I can reproduce this setup on the timer 4, then I will be good to go for the microphones. And also, if we have some time, I'm gonna try another configuration for the I2S peripheral, because we are gonna have some clock issue if we use the SPI/I2S peripheral in SPI mode. So we are gonna need to use it in the I2S mode. But if you remember from yesterday, I2S mode forces us to have an I2SWS pin, which is connected to the transceiver, one of the pins of the transceiver, which is actually the not slave select pin, not the reset one that I said yesterday. So quickly we are gonna start a new STM project because we don't need to start from the whole project that we have. We only are interested in using 2 pins on it. So, and while it's charging, loading, I'm gonna try to see if I can find, oh yeah, okay, beeping, if I can find to which pin I can connect on the Nucleo board. So this is all the pins on the device. What I'm interested in is timer 2, 3, 4 or 5. And it has to be a pin which is available on the Nucleo board. So one of those pins that we can see on the left of the screen. So we can see that there is timer 3, 5, 12 and 14. So we may be able to use the timer 5 channel 2 and 3, but I would prefer if we are able to use channel 1 and 2. So I'm gonna have a look if we can either have an access to timer 3 channel 2 or timer 5 channel 1. So yeah, it's those. So timer 5 channel 1, it would be PA0. And yeah, okay, it doesn't seem that it's available here. And we also have another connector which is available, which is this one. And we don't have any PA0 pin. Okay. Channel timer 3 channel 1 and 2, it's PA6 and 7. Well, maybe let's start on this one. None of those are available on the external extension connector. PA6 is here and PA7 is here. So that's nice. So that means that we should be able to connect to PA6 and 7. Alright, so let's try to look for our board. No, we are gonna use the board selector STM32F469i-disco. Timers tests. No, we don't want to initialize peripherals to their default modes. Okay, let's in the meantime set some music, which I again lost the link to, so no worries, just have to scroll and here it is. And this is the one. Let's pick song 200, why not? Okay, so loads of pins which we don't care about. Can we maybe, I think there is a way to there is a way to remove all the unused pins. Well, that's maybe too much. Oops. I thought there was a way to maybe really, we don't have any way to. That's weird. Okay. Anyway, GPIO. Maybe we can. Okay, let's. Well, maybe I don't need to reset them all. I need PA5 and PA6, if I remember correctly. So PA6 and PA7. Okay, let's check that I didn't mess up. PA6 and PA7. Yeah, that's it. Okay. So seems that they are unused, completely unused, so that's nice. Then PA6 is here. Timer 3 channel 1 and PA7 right below it, timer 3 channel 2. Okay, right. Now in the timers, timer 3, that's where the fun begins. So I'm gonna try to set the trigger source as ED for edge detection, because I think that's what we might want to do. And so we will have to enable the interrupts. So counter periods, let's try one. Counting up, we don't really care about that. So whenever we have a trigger, we reset the counter. Okay. then for the channel 2, the output we are gonna toggle on match, which I guess would be whenever we count up to 1, we toggle channel 2. Okay, let's try this. Generate the code. Hi Wojciech, how are you? So I just created a blank project and trying to test the timer with a scope and signal generator, just to see plainly if I can find a setting that is working. So let's close and use files so that we don't mess them up. Okay, we have timer 3. And then here I guess we have to call for timer, and then we have to start it. So I guess that would be I think that would be IC start. Okay, let's maybe still have a look quickly because I don't remember all the namings conventions. So here they do have everything I need to have a look at. So they use PWM start and IC start. So let's, oh no, sorry, let's copy that. So put that on the side, IC start and HAL, Tim, PWM start. And so what did they use for the channels? Tim, okay. So it would be Tim channel 2 and here Tim channel 1. So I have no idea if it's gonna work or not. Maybe I can at least have a heartbeat so that I know if things are working or not. So I would have to GPIO, toggle pin, and let's see in the pins that we have which one we could use. Are the LEDs placed or not? Are you kidding? So you placed, or maybe I reset it, so that would be a possibility. But you have loads of, loads of pins and LEDs aren't placed. Okay, let's see here. Which pins control the LEDs? Blue LEDs, nice. PK3. Okay, so PK3. Oh yeah, it's LED 4. Okay, it's placed here. Right. So that means that I can directly GPIO. It's LED 4 GPIO port. And LED 4 pin. So that should give us a heartbeat. Every 1 second the LEDs should toggle. I will quickly check the configuration here. So debug, we may want to use the serial wire debug. Let's use timer Is it advanced? No, we want a very basic timer for this. Basic timer, so timer 6. No need to use a very advanced one for something so basic. Hi Andy, how are you? This should be set to 8. And maybe I can try to okay. Okay, so we are just running full speed just because, yeah, we can. And also that's the configuration by default on the Nucleo board, so... Okay, don't think I need any more than that. Let's try to compile the code. Yeah, okay, generate the code. So what we are trying today is just a timer basically. So the timer 3 is basically the same as the timer 4 that we have to use for the microphones. And I have on my desk on the side I have the scope and the signal generator, which I will use to put at the input and output of the timer. So I'm just gonna try to see if I can find a configuration in which the timer is basically passed through for the clock. So sorry, yeah, okay, I have errors. Team channel 1, oh yeah, I'm missing an underscore. And I need, oh, it didn't generate the code. Yeah, sounds easy until you realize that I'm gonna have a hard time, I guess. Okay, perfect, no errors. Let's run it. So for now, you won't see anything, I won't see anything. I'm just gonna have a look at this page and see, so PA7, PA6, and I'm just gonna try to plug things on the board on the side. Okay, and pin for the grounds, which is here. Okay. just setting things up, so no worries, you are not missing anything. Interesting. What the hell is happening? Okay, so maybe it's time, maybe it's time to show you the screen of the scope. Okay, so this way I should be able to interact with the scope, and you should be able to see it too. So I don't know why it's the signal is a bit messed up. Maybe I can auto set. Okay, so here is my signal, which is super fast, like way too much. So that's not good. So let's see. Yeah, I think I should put it in external clock mode 1 actually. Or maybe just to see, I can add a measurement to see the frequency. So channel 2, enable it, and category, I just want to see frequency. Okay, we are 22 megahertz, which is it seems to be like 22.5. I have no idea why this frequency, probably because it is dividing by 2 the frequency that it receives for its internal clock. Anyway, I think that this configuration is more suitable. Maybe I can even use this one, trigger source, like this, and trigger on both edges. Let's see. Cancel. Need to regenerate the code. Yeah, I would need a second camera, but I forgot to set it up today. Maybe for next time I'm on the scope, I will try to use my phone as a webcam. Maybe I can even try to set it up now. Okay, I don't know if I already, yeah, okay, need to reprogram it, I guess. And maybe, can I add, oh no, I would need to, just give me a second or two. Aha. So I should be able to show you my setup. So if I do this, where is it? Video capture device. Okay. Yeah, okay, so just tell me if you think it's alright like this. Okay, so this is basically my setup. So I have the nuclear board here, and for now I only have the channel to the scope, which is connected to the output of the timer. Right here I have a signal generator, which is set on 10 kHz, 3.3 volts, and centered, so minimum voltage is 0. And so if I do this, and I rescale, I'm gonna set the source to channel 1. Okay, so on the channel, on the channel, the yellow channel, channel 1, you see that this is the pulses that the signal generator generates. I'm gonna try to connect the yellow channel. So I need to first connect the ground of the generator to the ground of the board, and then connect the generator here. Oh, sorry. Okay. Something definitely happened. I have no idea what. Oh. Oh, it seems that for whatever reason, it doesn't look like I'm on the ground that I need to be on. What the hell? Okay, that's a bit tricky trying to debug while having the cam in my hands. So the ground of the signal generator is connected to the ground of the nuclear board, and also to the channel 1 of the oscilloscope. So if I remove this and I connect this, yeah, huh, that's quite unexpected. Okay, Hi Bastien. Yes, le bel OCO. But le bel OCO is showing that something is going wrong. And I have no idea why. Okay, just like this. Right. Just let me check that I'm connected to the proper channels. So PA6 is the channel 1 and PA7 is the channel 2. So PA6 is the channel 1, the one to which I have to input the signal. PA7 is the channel 2 to which I have to read the signal. Okay. Maybe check that we don't have any. That would be no. That would be strange to have a jumper to switch from one to another output. I quite frankly didn't expect that. That's quite unexpected. Okay, let me have a look again. So it's connected to the correct pin, so that's for sure. I have no idea what I'm supposed to use for the trigger source. Maybe I can call for rescue. Ooh. So what if I try something different? No, okay, that's not right. Just try to. Oh yeah, Redman. So ITR, those are all internal triggers. I really believe that I do have to use either this or that. So that one wasn't working properly, and if I choose this one, then the channel one is completely disabled. Okay, so just waiting for Redman to connect to the stream and ping when he's here, so that I can ask him for help. So I really believe that I have to use TI1FP1, but then it seems that the channel 1 is set as disabled, but is still used as the, it's set as the trigger source. But then the trigger source, maybe I can just yeah, okay, so you will understand the problem if I do this. So the green channel is connected to the input of the timer, and it's always to 3.3 volts. I have no idea why. Channel 2. So why is it that my trigger input is high? So there is no push-pull or anything. Oh, maybe could it be due to this? The fact that I set maybe a falling edge, and thus it would have a kind of a pull-up? That would be weird, though. Yeah, no, okay, it's always high, which I don't understand why. Okay, let's check if PA7 is connected anywhere else. It doesn't seem like it. So it seems that PA7 is directly connected to the header that we are probing. Or maybe, heck, I know why it would be always high. The board is crashed. Board isn't running correctly, so there is a problem right somewhere here, I guess. Let's try to debug the board and see what is happening. I'm pretty sure that it might be due to this. Yeah, I'm gonna have to switch to debug mode and here compile in debug mode, switch to debug mode and debug. Okay. Yo, Redman. So here is my. Okay, I'm gonna grab the webcam again and show you my setup. So I do have my oscilloscope right here, which is probing right here the output of the timer 3. Right now it's probing the inputs. This is the input where I'm supposed to connect the signal generator, right here. And on the scope, which I can also show on screen for better readability, I'm displaying the generated signal from the generator and the output of the timer. So this is for the general setup. And so right now I'm using timer 3 so that I have access to both channel 1 and channel 2 on the headers. And so it's configured in external clock mode 1. Trigger source TI1 FP1. I'm not sure what TI1 FP1 stands for, but I think that's what I need to use, mainly because I found it in STM's code. Output compare channel 2 for the output. And so yeah, so it seems that for some reason right now my code is crashing, so I have nothing going on except this. So I just need to at least check what is going on. So right like this, I should be able to debug the code. What is happening? Okay, maybe I completely messed up the configuration and like nothing is working. Okay, so channel 1 is TI1 FP1 is channel 1 used as input, so that's what I indeed need. Yes, channel 1 input, channel 2 output. So this is my clock tree, but we don't need to have a look at this. It's supposed to be the same. Let me just check that I didn't make any mistake and have a look at what the original IOC file is. So yeah, that's basically the same as what I'm doing. Clock tree is saying, yeah, that's what I'm. The only thing that would make it not good is if I entered an incorrect value in the crystal value. But that's not the case. Yes, you can join my voice. We can go into the M17 live room if you want. So I'm just gonna turn off the music. Sorry guys, so yeah. Hi.
Okay, do you hear me?
Yes, I hear you. I guess we can hear you in the chat and the stream too.
Perfect. Okay. Oh, yeah, hi.
So right now that's weird. That's not supposed to happen. I'm not even able to start debugging the chip, which is yeah. I never had this problem before.
Let me see.
Maybe
it does not even go in debugging mode. Can I see the code, please?
Yes.
I suspect a null pointer, the reference.
Well, the code is as vanilla as it can be.
Okay.
Oh yeah, I had. Oh maybe okay. I wrote in the
handle to timer freeze initialize somewhere.
Wait, I'm just gonna put heartbeat. I wrote it, but I think I wrote it outside of the boundaries.
No, okay.
Okay, so this is the heartbeat that I need. Let's quit any debugging thing or whatever. Yeah, 2 voices. So yeah, it's I initialize the HL. Those functions rarely have any problem. Then timer 3 init, which is initialized with all the settings that I showed earlier. So here, and then I called those 2 functions, which are the one that STM calls in their code.
It's perfect. It's okay. Now, what I'm wondering is the HTML3 handle. Where is defined? I mean,
right here.
I'm not really used to CubeMX.
Yeah, I guess so.
I usually go straight to registers.
Yeah, I guess even when you are used to CubeMX, it's not great actually.
Yeah. Okay, it's defined there. Then yeah, it should work.
So if you have a look here, that's how they initialize it.
Yeah. Okay. We can try. Well, please go down. Yeah, that's a bunch of stuff.
Yeah, maybe can I maybe
to the main.
Share my screen?
No, it's okay.
So that you see it with less latency.
Yeah. Okay. Loading. Come on. Okay, Discord decided that
Ah,
it doesn't
yes,
like
sometimes
work.
it does that.
No. Hold on. Yeah, it doesn't like streaming. Let me join using private browsing. Coming in
So you're
couple
using
of seconds.
Discord on a browser, is it?
Yeah.
Okay,
Coming in a couple of seconds.
no problem.
Okay.
Oh, I think I know why it wasn't working properly for the debugging.
Krunk. Okay, here it is. Oof, it's so small. No, picture in picture does not make any sense.
Yeah, no, it's still not good.
It's damn small. But I have full screen. Nice. Okay. So, yeah, init function. It should be okay.
Yeah.
You can try comment out lines 92 and 93.
Just gonna, yeah, maybe try debugging it like this, but it should. So I don't know if you use this IDE very often.
No.
I guess so. Basically, whenever you use the debug mode, it's stopping
Yeah.
at the first instruction of the main. So it should stop, and there
okay.
is always a breakpoint at line 75.
Yeah, okay. Does it tell you? Okay.
And so it's showing like no source available for main, blah blah blah, but it should show it up here.
Download verified successfully, okay.
I'm trying to think what I could do to at least. Okay, I think I'm gonna. Sorry, for now, yeah, it's actually not that much related to timers.
Disable everything.
Let's.
Oh well, you can keep GPIOs.
Yeah, I'm just gonna reset a few. That seems kind of useless. LCD interrupt, don't need that. Micro SD detect, don't need it. So as few things as possible. So RCC crystal, that's what needs to be set.
Yeah.
Okay. So generate the code as always. Build debug. Yeah, I'm not used to it building so fast. And debug. It says release, but it's using the debug binary. It's supposed at least to do that. And it doesn't do that, it seems. Okay, I'm getting very confused.
So it seems the problem is running the code.
Yeah.
Nice.
That's, yeah, you never know with STM whenever you are gonna encounter a massive problem.
Yeah. It's the first time Well, is it remote debugging?
No, it's not. It's plugged on
Okay.
my computer locally.
Okay. Okay.
I tried remote debugging, but then I had another set of problems with STM.
Okay.
I feel like it's gonna be the running gag of this series is how bad can STM be.
If you want to try, we can go straight with well, um, we can either flash it using the STM32 flash tool. Otherwise, we can go GDB command line.
Okay, I think there is a problem here, which is that it's supposed to... there is only the release one, but it's supposed to also have the debug one.
Yeah.
So let me just try with that.
Waiting for the bugger connection.
Sorry.
Okay, verifying, blah blah blah. Come on.
Download verified successfully.
You're happy for that?
Wait, where is it? Oh no, okay, it's good. So yeah, that...
Okay.
So if I do this, I should have...
Oh, Jesus.
Which, no, I don't. Why? Okay. I should have the... okay, let me bring the boards. So I expect to have LED 4, which is the blue one, to be toggling, but we don't have that.
Okay. It's still.
Because we are...
Stop.
Huh? What?
We are stopped at the breakpoint.
What the hell? What is this code stack?
What?
Shit.
I'm afraid we have a problem.
Yeah, I'm afraid I
just a
have.
little bit.
Okay, you know what? Let's
Just
restart the IDE.
Oh my god.
I have no idea what's going on. Hell, I restarted a project just to have the code as bare as possible, and then...
Yeah.
Let's try to see if restarting it does solve the problem.
Now, if someone asks me, why don't you use Cube IDE? I think I have the answer.
Yeah, I definitely think that it's not...
I mean, I usually go directly command line with GDB. And that's it. At least it just works.
Yeah. Yeah, I had loads of problems with the screen, actually. So it's initializing a whole lot of...
Yeah.
Maybe that's what is happening, is that it's initializing a whole lot of GPIOs which are not needed and unconnected, so it may be hanging because of this. Because yeah, we just saw all the initialization code for all the GPIOs that we don't use, and you can see that they are connected to SDIO D3, for example, so
Yeah.
it's initialized as a peripheral input. But as there are a lot of pins, it's taking some time.
Yeah.
So...
Well, you can probably directly kill...
I thought that there was a possibility to clean all the pins.
Yeah.
Or maybe, yeah, can I...
clear pinouts.
Yeah, but I think it's gonna reset everything. Yeah.
Yeah. Ah,
But maybe then I can just go
Jesus. RCC.
do this,
Crystal oscillator.
do this.
Yeah. SWD. Well,
PA6.
SWD is the default, so.
Yeah, yeah. Just gonna I set it that way. Anyway.
Technically, when it goes out of from boot, those GPIOs are already configured as.
Okay, so and I also need the LED 4 to have a heartbeat, and LED 4 is connected to PK3.
Yeah.
Okay, let's retry this.
Yeah.
So, oh,
It works.
it works, but now it seems that it's directly going to the error handler, is it? Oh no, maybe not.
No. Why?
Well, but my LED is still not blinking.
Let's just config. Oof. Is it running?
Well, should be blinking, but it's not.
Okay.
Oh, I'm getting so bored. Did I forget something here? I don't think I did. I mean, you can't have less things.
Time-based source. No, why? SWD is... You can take serial wire, it's okay.
Yeah, I can disable it if needed, but
no,
that won't be changing anything.
Yeah. Go to RCC again, please.
Yeah, sorry, here.
Yeah, that's it. Ceramic resonator should be okay. Should be okay. GPIO settings. Yeah.
So that's basic.
Yeah. It's 8 megahertz. Then you select this one. Then PLA.
I can try to slow it down if needed.
No, well.
I mean, at the point we are at.
My goodness.
Okay, let's.
Is the crystal 8 megahertz?
Yes, it is.
Okay.
I'm trying to find it.
What are the other options for the high-speed clock source?
For which clock source?
Window. Yeah, no, in the other page. Sorry. In the drop-down menu, in the other page. There.
Bypass clock source. Okay. Maybe. Yeah. You know what? That's a good point actually.
It's okay.
You know what the board does have? Oh yeah, it's there is.
Yeah, it's crystal. Okay. When you put it into bypass is when you
for TCXO or something like that.
Yeah, an external clock source which goes directly into the.
Yeah, I just wanted to check that it indeed had a crystal on the board.
Yeah, they usually have crystal basically because it's cheap.
Yeah.
So, from their point of view, it does not make any sense to put a precision oscillator.
Yeah, sorry, misclicked. I just want to try. So this one, it's gonna be debug, build configuration debug, debugger, blah blah blah. This. Why? There is still something wrong. I can't remove the release elf file. And so here I'm gonna put it in a release. Oh yeah, maybe I think maybe I like this.
Okay. Release.
Yeah, okay. That makes more sense.
Yeah.
So that maybe that's why it was showing a weird stack, because it was trying to find functions and so on at places which were not coherent with the assembly code. No, sorry, what did I do? Okay, no, it's blinking.
Oh, at last.
And we have quite an audience in the Discord channel, I see.
Yeah. Yeah.
Hi guys. So yeah, it's the debugging group activity.
Yeah.
So okay, now, woo! Now that we have the blinker going, what if I retry to debug it?
Don't.
I will.
Please don't.
I already clicked. But I'm confident that we might have something. Yeah, okay. It seems. Hey, it's blinking. And if I pause it and I have a look
it
here.
Stops. Okay.
No, okay, good. It's all right. The stack is looking good.
At last.
At last. Okay. Yeah. I just want to say that so yesterday I was like, I will try to record a sound file, and now I'm just like, yes, the LED is blinking. 2 days later.
We made progress.
Yes, progress it is. Okay, then now we can focus on the timer, and now you are really gonna be useful, I think.
Okay.
Timer 3 channel 1, timer 3 channel 2. Timers,
yeah. Okay,
timer
so
3.
What is what? Channel 1 is input.
Yeah.
Okay, so slave mode disabled. Okay, trigger source is ETR 0 because they are
ITR 0?
I think so.
Okay.
No, the disabled trigger source is disabled. Sorry.
Yeah, I do need to set external clock mode 1 to slave mode, is it?
What are the other options?
I do believe that this is the configuration that I usually need to use.
Channel 2 is output compare match. Yeah.
Okay.
Sorry, for slave mode, what are the other options?
Slave mode, those.
Yeah. Okay. It's okay. Okay. Then. Perfect. Then press scalar is 0. Counter mode up. Counter period is 1. No. Counter period should be 2.
To divide, they use a period of 1 to divide by 2. But anyway, as we can put whatever we want, as long as we have a signal which is coherent and we have a configuration that we can test and then improve upon, then we are going to be able to find.
I usually put it to 2.
Okay.
Then internal clock division, okay, and oh yeah, because they put the auto reload register to 1, and the compare match register to 0. Yeah, okay.
Okay, so I set it to 1.
Yeah, you
Okay.
okay. It's fine. Auto load disable, well, that's okay. And trigger output parameters is not needed. Output compare, yeah, that's okay. Rising edge. No, that's trigger. It's to start the counter, but we are not
Okay.
using it, so we can leave the default. Mode is what are the options for that? Mode. It's active level on match. Pulse
I
zero.
shouldn't I use toggle and match? If I want to my output pin to change level.
Let me think.
Okay,
No, the point is, if you do active level match, let's say we have a counter which has an auto the value of 2, and you put compare value 1. If you set active level on match, you get that when the counter goes to 1, the output goes high, and then it goes low when the counter does the auto reload.
Oh, okay.
It's used for PWM. Basically, you are generating.
Okay.
So, well, let's keep it to active level match, and toggle on match. You basically yeah, with toggle on match
Well,
you are going to
in
divide it by 2.
this, okay.
So, how to compare preload disabled, and probably we are done.
Should I set it to enable?
Not really.
Okay.
Let's see if it does something.
Okay, so let's generate the code. First, I'm gonna try to run it. Oh, but I guess I'm gonna need to uncomment those two lines.
Yeah. Well, no. I mean, I'm expecting it generated everything already.
You think?
I hope so.
Post in it doesn't call any start function, I think. Hi, Liberty Cave WS7PB. Glad you like the project. So lots of people are reading your comment and liking it too, I believe. So in the voice chat, I think they can confirm. So okay, blinking.
Okay.
Which is great.
Yeah.
So then I'm gonna put it back here. Okay, let me just. Okay, I'm gonna re-enable the camera on the stream. Here. Okay. So I need to connect this here for the grounds, and so this is the output. So I set the outputs to the oscilloscope. For now, the output isn't moving, which is to be expected because we have nothing at the inputs. And
Yeah.
so what I want to see is, yeah, okay, great. So I connected the inputs.
Yeah.
At least now the input isn't moving when I plug it to the.
Okay.
So Yeah, that was because the input was being stuck high for some unknown reason. Now it's not anymore, so okay. I'm gonna get back to the computer and remove Droid Cam right here. And we have the scope here. I'm gonna move the ID on the sides. No, maybe I'm just gonna... Okay. So now I'm gonna try to recompile it with those two functions.
Okay.
Okay, it seems that it's not working.
Okay. Does it have any?
Yeah, I think it.
View?
Oh. Okay, it's blinking, but the input. It's like the input is being pulled low.
Yes. Oof. Oh, yeah. Let's go to the GPIO configuration. Haha. Yeah. Of course. The input should be no alternate function. The input should be alternate function.
Open drain.
No. It should be input mode.
But it won't be configured as an input if it's an alternate function. That's not possible.
There is a alternate function input.
On CubeMX?
Let's go back to the timer again, please. And then go to GPIO settings. And then there. Yeah.
Nothing's happening.
Oh, Jesus. Yeah, it's frustrating.
I'm just gonna try if I do this, does something
No, the point is that the dumb configurator must set that input, the channel 1 as alternate function input. Input needs to change the trigger
I think it does something like that somewhere.
I have an idea.
Yeah, tell me.
We can try to force it.
Okay. Yeah.
We can bend it out to our will. Let's go. Yeah, to the what is the post init, which does the GPIO config.
GPIO init, it does enable all these.
Is it in all post init something? Whatever.
Yeah, you're right. It seems that I don't know where it does its
not there.
Initialization. Oh no! Okay, no. I think it's.
No, it's not there. You have to go in HAL team init.
HAL team init.
Yeah.
So HAL team init.
Go down, up. Oh, sorry.
Yeah. Okay. Yeah. HAL. Okay. HAL team base init.
No. Down. There. MSP post init.
Oh yeah. Okay.
Inside there.
7. Okay. Let's go in it.
Okay. Yeah.
So this is the output.
Yeah, that's the output, and that's okay.
But I believe that it's gonna initialize the input actually right here.
Oh.
Maybe channel. Does it use any GPIO? No, it doesn't. Huh.
Oh, listen, let's do a control find for
So that would be
well, it must configure PA6.
wait, I just don't know what I have to look for. No, sorry, getting confused.
We can try to do control find.
Yeah, yeah, I can do control find, but what should I have to find?
PA6.
PA6?
Yeah.
No, yeah, maybe in the comments then, but I don't think it's...
yeah, it should be in the comments. PA6. Aha.
Oh,
okay.
Well done. Base MSP init. Mode alternate function push-pull.
There should be a GPIO mode alternate function input.
That doesn't exist. You have alternate function push-pull or open drain. You know what?
Let me see.
Try quickly GPIO tim timer 6. Use it as open drain.
No, it's not open drain. Open drain is output. It's
well,
output. Oh my. Honestly, this is one of the reasons really big of why I hate CubeMX.
Yeah.
And I go straight to registers.
I get it.
This said, apart from ranting against CubeMX, external clock mode 1, T1 FP1, output compare, that's okay.
I'm just reviewing everything we did.
Unless you don't have to assign the input to try going to timer free channel 1 on the GPIOs.
I can't click. Oh, GPIO, sorry.
No, yeah, on the pinout view.
Yeah.
On the pinout view. What if you click there to configure it? GPIO input.
Yeah, but then if I go back to timer 3,
it goes boom.
Then it's gonna pick another GPIO as an input. It's PB4.
Yeah, my god. No. Okay. T1 FP1. No, let me take the reference manual.
Okay, so we have Polo in the chat that says that he thinks that perhaps the timer trigger settings is incorrect. But what should we use then if it's not TI1 FP1?
No, it should be TI1 FP1. Quite sure.
ETR1 and then input capture direct modes. Well,
Let's see the reference manual.
Let's try these settings maybe. Okay, well, at least now it's not
Okay.
it's not pulling the input down to 0, but the output isn't moving.
Mm-hmm.
So channel 1 must be an input, yes.
Yes. It should. But yeah, it must be an input. There is no choice. I don't remember. Yeah, it should the GPIO.
Sorry?
Mm-hmm. Now I'm checking the reference
Oh,
number.
we have ETR, yeah, but okay. ETR is creating a third GPIO, so that's not,
Let me
that
take
can't
the
be it.
now functional description. Yeah. Counting modes. Clock selection.
Yeah, Wojciech, don't worry about that. Yeah, we are gonna try a bit more, and then we are gonna leave it there, and I'm gonna have to find a solution at some point to have this working.
Yeah. I have a board around. And I mean, it's really something I already did.
Yeah, I guess that seems like kind of basic. So
yeah, it should be not TI1 FP1 because it's filtered and go to the capture compare register. It should be oof.
TI1 ED maybe.
No, let me see. No. Jesus. TI2. TI1F.
Well, now it's the output is always high.
At last. Let's go back now, again to the CubeMX, please. Okay, the option is external clock mode 1. And then that's okay. Now the trigger source. Let me see. ETR is internal trigger. Okay, try again with TI1 FP1.
TI1 FP1.
Why channel 1 is disabled?
Because it's automatically switched as the trigger input. So we can't reuse it.
Okay, I'm starting to get tired.
ETR1 would be external triggered by a dedicated ETR pin, I believe. Because if I go to this pin that I'm gonna...
that's another option again.
Yeah, but I'm explaining to the chat, so that's timer 3. You see that I don't have any timer 3 ETR on the possibilities for the pin that I want to use, so it can't be that. So it has to be TI1 something, and so it's either FP1 or ED.
Or is TI1F ED?
TI1 FED?
Yeah,
don't have that.
TI1 ED. I'm looking at the block diagram, and probably TI1 FP1 and TI2 FP2 have to be used when you are using an encoder. But channel 1 What's the option for channel 1? No.
Sorry, it's loading. So it's either disabled or input capture triggered by
No.
TRC.
No. I can try looking at the datasheet tomorrow morning. And
I think what we are gonna do in the end is use CubeMX so that we have an overview of which pins are used and so on, and which pins are used for by which peripheral. And then we are gonna tell CubeMX not to generate any initialization code, and we are gonna initialize all the peripherals by yourself.
yes.
I think that's the most sane option.
Yes. I mean, because if you take the reference manual and you look at the documentation of the register, you can use timer 1 channel 1 as input. I'm quite sure.
Yeah, timer 1 channel 1 is used as input here.
Yes. But it's misleading the configuration. I don't understand, for example, why it forces it out as alternate function output when it should be an input.
But I don't really know. Alternate function is yeah.
Yeah. Wojciech sent.
Yeah, but the problem with these links is it's not that they don't work, it's just that then we still have the same problem that we have with the original problem is that I don't want to be just reusing BSP functions because I don't understand what it does, and every time I try to modify it, it's very weird. So I would like, for now, at least until tonight, try to use CubeMX. If we can't, then we are not gonna use CubeMX, and then we are gonna do it by hand.
Okay. Let me check again in the meantime. Clock selection. Okay. It says counter clock can be provided by the following clock sources. Internal clock, and that's okay. External clock mode 1, external input pin TIX. External clock mode 2, okay. The internal trigger ETR, using one time as a prescaler for that time, but it's not our case. It's doing something.
It's doing something. Gonna use the... Okay, I'm dividing the signal by 2.
Oh. Wow.
So I guess...
What was it?
TI1ED, and in the output capture toggle on match.
Yeah, okay, that's toggle and match, that's okay.
And then output compare preload enabled. And so now if I put 0 here, let's see. Okay, nothing is happening now.
Yeah, you put 0 where? Sorry?
Sorry?
You put 0 where?
At the prescaler for the counter.
Counter period. Auto reload register. Yeah, the auto yeah, because if the auto reload register is set to 0, then the internal counter is kept to 0 and there is no compare.
Yeah, okay.
So it should count at least 1.
But then I'm thinking that maybe we won't be able to use it as a pass-through.
Okay.
Which would be very annoying. If I do this, but I think it's still gonna pull the input low or something like that.
Yeah, it screws up again the channel configuration.
Yeah, so it's
That's
the input channel is pulled high for some reason, and so it doesn't like it.
It should be TI1ED.
Yeah, I believe so. I just thought that maybe I could set the trigger to trigger on.
But the trigger is another thing. I mean, the trigger is a mechanism you can use to start the counter
Okay. Yeah. Okay.
on a specific rising or falling edge. When you have to, yeah, for example, to count the time between two events, you set the trigger and so on. I mean, for example, you want to measure the period of PWM. You can set you set the start of the counter on the, for example, falling edge.
No, I messed up something again.
TI1ED.
It's
channel 1 input capture. No, it's not an input capture.
So it's disabled?
Yeah, it's trigger source. I mean, it should be disabled.
Okay.
I think. It's really messy.
Now it's pulled down. Oh god. I should have written down the settings.
I'm dying. Okay. Input capture. Input capture channel 1.
Input capture selection.
No, go again. Okay. The scalar is 0, counter mode is up. The internal clock division or division auto load enable slave mode. Slave mode controller. External trigger mode 1. That's me. External clock mode 1. Oh, okay. I got sick. Let me check the damn data sheet. Slave mode controller. SMS, slave mode selection. External clock mode 1. Rising edge of selected trigger clock the counter.
I really do think that now the problem is that we won't be able to divide the clock by 1, only by 2.
Okay, yeah. So now it's divided by 2. Yeah, but try changing the output to the channel 2 to output on compare match.
So, sorry, what?
Go down, please. Instead of toggle on match, High active level on match.
Okay.
Let's see what happens.
But I think it's gonna go high and then stop and stay high.
Mm. Mm.
Yeah,
It goes high and then it keeps.
it stays high.
What are the other options on channel 2?
Frozen, inactive level
And-
unmatch,
and-
forced active, forced inactive.
No, sorry, on the upper, in the mode window, the upper window.
Upper window.
Yeah, there.
Oh, PWM generation channel 2.
Yeah. I wanted that one. PWM mode 1. Pulse is 0 because the counter goes. Well, let's see. Alternatively, we can set pulse to 1 and the other to 2. But no, it still divides.
Something happened and then nothing.
Okay. No.
No.
I'm afraid we can only divide by 2.
I think that would make sense with respect to what we are seeing.
Yeah, because we are counting basically the rising edges on the input.
Yeah, and
So even if we put it in PWM mode, it needs at last 2 clock inputs, 2 clock pulses to do everything. Because the counter is clocked by the input, so for sure it divides by 2. There is no.
Wait. No, it can't be.
There is some magic. Some magic is going on. What?
No, it's good. Except that it's reverse polarity, but that I guess I can change somewhere. Can I?
Time to go to bed. Okay.
Channel polarity. Let's use low.
Oh my. Finish.
Maybe we would have been faster if we just rolled our head on the keyboard.
Yeah, probably yes. I believe in magic. Yes. Now you touched it and it doesn't work anymore.
Yoo-hoo! Look at that.
Yeah. Perfect.
Okay, now just gonna have some fun. Gonna enable the cam and go to the signal generator
Yeah.
and see how fast we can
Yes, because now the counter is clocked on the both edges. Of course. It seems to do something, so.
So 160 kilohertz still working.
Okay. That's good enough.
1 megahertz still working, but we have a slight
1 megahertz. Yeah, okay, 1
Shit.
megahertz it's fine. Keep going.
2 point. Okay, let's reach 3 megahertz and rescale the display. Okay, we see that we have some kind of jitter and now it's kind of getting out of sync.
Yeah. Oh well, because the input probably are not set for high speed operation.
Might be, but yeah, well, I reached the maximum frequency of the generator.
Okay.
Those signals are as ugly as possible. But what I'm really interested in is what it looks like when I'm at 1.024 like this.
Oh well.
And there is a slight shift. I think that it should be alright, except that I'm just gonna try to see if I can remove this shift by so I set pulse to 1, maybe I can set it to 0. Oh no, I can't. Oh, okay, that's not what doing what I thought it would have been doing. Okay. Do you know what PWM mode 2 is?
I have to let me check.
Yeah, if you are too tired for that, don't worry.
No.
Just gonna try a few settings.
Let me check.
It's all on the stream, so if I mess up something, I can rewatch the stream and see what I did.
I probably have to go soon. Description. PWM mode. Let me see. PWM mode. Edge aligned. Yeah. Oof. One is. It's not really descriptive. I mean.
As always, I would say.
Oh well. ST datasheets are quite good. I mean.
Datasheets, yeah, I have to admit.
Reference manuals too.
They are not that bad.
I found in my life worse reference manuals.
The worst thing I had was that, so for another project at work, I used the STM32WB line of product.
Oh my, yes.
Bluetooth. So you know they have it, they know they have it. You are looking for the dock, they are looking for the dock. So yeah, it took me like weeks before having something which was remotely working, and then finally, step by step, I managed to get everything working as expected and quite well actually. Even found a way to enable one of the features that they talk about but didn't say too much about.
Okay.
Oh, people are happy in the chat. And yeah, people are also finding that STM documentation is hard to find. Yes, it is hard to find.
What you want. Yeah.
And sometimes you find it and it's not like my main problem, but then maybe I'm too naive, is that they offer a product which is called CubeMX, which is supposed to take care of all the boilerplate and typical initializations that you don't want to do.
We saw how much it does take the boilerplate.
Yeah.
But the point is that with a good datasheet and with a good datasheet, you can configure this stuff in like 10 lines of code well documented using the right amount of comments
I agree.
by setting values in the registers, and you are done.
I agree.
This is one of the reasons why I don't like really the CubeMX, because I don't see the point of filling a data structure with configurations and then to have some piece of code which greens this data structure
Well, I
to
don't
write
see it.
directly in the registers. I mean,
I don't see it as using data structures. I see it as using a program which is gonna take care of all the low-key stuff that I don't really want to be doing all the time, and that tool does need data structure for that.
yeah. CubeMX is visual basis for the of MCU. Yeah, I would say so.
So I guess
I went out of the stream. Oof.
so yes, you have to find the datasheet, but also sometimes you have to go through all the application notes that they can have. Sometimes you have MOOCs that they do, but are not always that great. And sometimes you just find documentation for something which is like 3 or 4 years old that they have reworked a few times already, and it's not up to date anymore.
Yes.
That's what I had for the Bluetooth thing.
Well, my worst experience was with a peripheral made by Bosch inside a system, basically a processor for automotive ECU. But the problem is that that piece of hardware made by Bosch was poorly documented.
Yeah.
And it had bugs in hardware.
Oh shit. That you don't like.
The bugs in hardware pop up when you push it basically to 10,000 RPM, which is the standard for motorsport applications. Okay. And since I was working on a device driver for MotoGP, for us, like 10,000 RPM is the standard. For your car isn't.
Yeah, I guess.
And that chip was
10k RPM on my car, I would be running off.
For the serious cars, which do basically 3,000 RPM at most.
Depends on if you are using gasoline or diesel.
Yeah, but I mean, when you go to 4,000 RPM, then something is going wrong.
Some gasoline cars do go up to 6,000, I think.
Okay,
but
if you
it's not the cruise speed.
Yeah, and 6,000 RPM for a MotoGP engine is the standard when you are standing still.
Yeah, definitely not the same.
when you are at the pit lane waiting to start.
Yes, Bastien, your diesel can go up to 7k RPM, but then it's only gonna do that once.
Yes.
Yes.
Okay, anyway, long story short, we had some bugs in hardware and very poor documentation. And well, it ended up well, but you know.
Yeah, how much time did you lose tracking down those bugs?
6 months.
Holy, that's a fair amount of time.
6 to 7 months.
Oh god. Oh man. And so did you change the device, or did you just manage to find a solution?
We found like a bunch of workarounds.
Yeah, okay.
So but anyway.
Oh, so that's one weird layout for the microphone. You have a ring of ground around the pads, so you cannot have any track going under the device.
Oh, after having seen inverted F antennas, I probably see so everything. Or some cheap antennas that basically are short circuits.
Oh yeah, yeah, but no, I mean this is alright, but I mean for the layout thing that you can't have a track on the same layer as the device. So if you have the device on top, you can't have a track on top going under the device to the pin 1, 2, 3, or 4.
Yes, you have to put vias.
Which is a weird choice.
Only weird.
Only weird. It's okay. Guess who manufactured the device?
Obviously.
Obviously.
Plus you have weird timings.
So what I wanted to have a look at is okay, what the so I need to have a look at, so because we did manage to divide the clock by by 1, which is nice. So basically not divide the clock.
Yeah.
But now I want to be sure that the delay in the clock is not gonna cause us any problem.
It depends on.
So the microphone I wanted to use is the one, so U1, and U1 is connected to LR is connected to ground. So that means that ground, the clock is low, the data is valid. So that means that we have to sample on a rising edge. So, okay, right here. So okay, so it's all right actually.
Okay, so we should see something on the scope at least.
What should we see?
If it spits out data.
No, it's not connected to any microphone yet.
No, yeah, okay.
Yeah, this is just so. This is an empty project with an empty timer just to check the configuration.
Yes.
MCU clock frequency is a good ID. Let's check that. Maybe it is gonna
180 megahertz. Full throttle.
Yeah, full throttle indeed. No, it's this and this. Yeah, okay. So now it's full throttle, and is it gonna change the offset between the two rising edges?
No. I mean, I'm not expecting to do so. If they did the preferred well.
Which is quite an assumption already.
Yes.
Okay, maybe. Well, it did improve it.
It did.
So. I think it's because they clock the edge only upon an event of the internal clock. You see what I mean?
Yes.
So that's why
it
reduces the delay. Preload option. Oh, maybe that could be that the preload.
The preload option works when you have when you want to change the PWM on the fly. But since
Okay.
the values are the same, I'm not expecting particular changes.
Well, it did change the polarity. I didn't expect that. Okay, let's keep those settings. I'm quite happy with that. And if we try to track down any useless delay, that yeah, we just are gonna create some more problems. Output compare preload, it's already checked.
But wait, if the sensor is giving out data on the falling edge and we are sampling it on the
No.
one.
That's the trick. It's not giving data on the falling edge. It's giving data on the clock low. And so when the clock goes high, it's gonna go to high impedance. And so actually this is not so bad that what we have. So the sampling clock is the yellow one and the microphone clock is the green one. So it's giving us a signal on the green low, and so we see that we are sampling it right still while we are sampling it, so yellow rising edge, while the clock is still low. So that way we shouldn't have any problem. And
yes, yeah, my point was, even if we have some jitter, probably we are safe.
We won't have any jitter, I guess. But even like I'm trying to, we are 3 megahertz, and I guess we are still good. Let me just. Let's try to measure this delay.
Now it's half of a cycle. It's a quarter of a period, more or less.
So we have like about 50 to 70 nanoseconds. And I think oh no, that's not the one I wanted to measure, but it's gonna be the same thing anyway. Between this and that, yeah, we have about 90 nanoseconds. And so when the clock goes low, the delay before we have any data on the output is TLEN, which is 40 nanoseconds. So even if we were to sample at 3 megahertz, which is more than we need, we are safe.
Okay.
Great. Okay, nice. I think I'm not gonna be much longer. So anyway, Redman. So what's your name actually?
Silvano.
Silvano. Oh yeah, sorry, I forgot about that. Silvano.
Yeah, don't worry.
So thank you very much, Silvano, for your help.
You're welcome.
Very much appreciated and very useful.
Let's see for next sessions.
Yeah, next.
If I have time, I will join.
Oh, that would be great.
I mean, if I'm not completely destroyed from
yeah
from work.
Yeah, I get that. No worries. I'm gonna try to reproduce those settings. Okay. So just gonna have that here, and That's right here. And yeah, also after that, so yeah, one of the things, let's just give us something to complain about a bit more, let's say.
Okay.
I don't know if you followed the problem that I had yesterday.
Yes and no.
Yes and no. So
I mean,
let's have a look.
Yeah, that problem.
Yeah. So
Okay.
this pin, transceiver not slave select, which is used for the communication with the SPI bus, because this one is free. So I wanted to first use the I2S3, but I can't. Because why? It says that PA15 is mapped to a GPIO. So, oh shit.
Yeah.
But on chip, those are the exact same transistors as SPI3. So I can select SPI3, receive only master maybe. Well, no, because you have to use SPI3 MISO and not SPI3 MOSI, which is the pin which is connected to the microphones. So you have to put it as half duplex master.
Yes.
And keep it in reading mode.
Okay.
Then you say all good. What's the problem?
Yes.
Well, the problem is that baud rate 22.5 megabit per second, which is way too much.
Yes. And you can't divide it.
If I want to divide it,
Down.
I guess I have to modify APB1 clock.
Why? Oh, no, yeah, okay, but we have...
Which I could do, but I don't want to do that because I'm gonna slow down a whole bunch of things.
Yes.
So, in the end, you still have to use I2S3 as a peripheral, because when you use I2S3, then you have access to PLL I2S, which allows you to select the frequency much more accurately. But then that means that I have to remove this pin. So let's remove it and set it as half duplex master.
Yes.
And it's replaced by a word select pin, which is completely useless.
But
you can generate the code and then comment out the GPIO setting.
Yes, that's what I
can change by hand that dumb GPIO.
Yeah, so I'm not gonna set it as an I2S3 here because what I'm gonna do is set it as SPI3, half duplex master, blah blah blah. So that way I still can have GPIO output.
Yes, but you will have to change the alternate function mapping.
No. What I'm gonna do, so that way I see on the map which pins are used by which peripheral. And then tools, project manager, code generation, advanced settings, SPI3 init, I don't generate the code. And I'm gonna rewrite the initialization by myself.
Okay.
So basically I mute CubeMX.
Yeah, okay.
But now I can also go to timer 4, slave mode, external clock mode 1, trigger source TI1 ED, TRC, PWM channel 2, 1, so yeah, I think I forgot to take a screenshot of the, oh no, here it is. Channel priority high and fast mode disable, enable. Okay, great. So now we should be able to sample data from our microphones once we have initialized I2S3 correctly.
Nice.
which I'm not gonna do now on stream. I'm kind of getting tired. I've been online for, well, 2 hours now.
Wow.
So, yeah. I think it's time to say goodbye. So again, Silvano, thank you very much for being here. It was nice also having somebody to discuss with on a more real-time basis than the live stream. Yeah. Okay, so yeah, audience is clapping. Thank you guys. Thank you to you two for being here tonight. As always, I hope you enjoyed this. Even though we are raging against STM, I'm still enjoying doing this, so don't worry. And it's easier to find the mistakes than actually admit that they do make a whole bunch of products, which in the end turn out to be quite useful and used by billions of projects everywhere. So it's not as bad as we make it seem, I guess. Just in case an STM representative is watching. Okay. Well, bye bye everyone. 73s to everybody, and